Alright, so this video is about solving system of equations using matrices. Lots of times you hear this called augmented matrices. Augmented. So whenever you're solving a system of equations using matrices, a lot of times it's called augmented matrices, and this is the reason why. If I gave you this system of equations in 3 variables, you may have learned in a previous algebra class that you can isolate 2 of these variables in 2 different equations, solve it for those variables, come back, replace it in, and eventually solve for all 3. You might also know it sometimes can take pages to finish this. So it's really nice to know that matrices can simplify that process. So the way we use matrices for it is we take all the coefficients would be the numbers in front of the variables, we make one matrix with them. So it's going to wind up being, the first matrix is going to be -3, 2, -6. The second row is going to be 4, -5, and +2. And the next matrix is going to be, next row is going to be 7, 9, and 3. And then because we took all the numbers off, the letters get its own matrix, and it's going to be a 3 by 1. It would be X, Y, and Z. And it's going to equal to the equal side. These numbers, 14, -3, 14. So 14, -3, 14. I would call this matrix A. I would call this matrix C. And I would call this matrix B. And if I was going to solve this equation for matrix A, solve the equation matrix C to get C alone, so I know X, Y, and Z are. I would essentially take A inverse and multiply it on both sides to get A isolated. So essentially our equation right now says this. Our equation currently says A times C equals to B. And to finish that, I'll multiply the left side by A inverse and the right side by A inverse. And what's really important is A inverse go to the left of B, or else it doesn't work. It gives you something invalid. So A inverse has to be on the left side of B. So A inverse times A is the identity matrix, and that's going to equal to A inverse times B. But identity matrix is essentially the same thing as 1. So what we're going to have now is C is equal to A inverse times matrix B. And this is what I'll plug in my calculator, A inverse times matrix B. So I'm going to pause a minute. I'm going to plug in matrix A in my calculator and B in my calculator. I'm going to find the value of A inverse times B. Alright, so what I've done already was I've inputted matrix A as to be a 3 by 3 matrix, and these are all the elements of matrix A. I've already plugged them in, and then I inputted matrix B as a 3 by 1 matrix, and these are the elements of matrix B. So basically what I'm plugging now is A inverse times matrix B. And then the product is this, 2, 1, -3, 2, 1, -3 in that order. So that means C is equal to 2, 1, -3 in that order. Since C was represented by X, Y, and Z, that means that X is equal to 2, Y is equal to 1, Z is equal to -3. So that's the solution to that system of equations, 2, 1, -3. And I could take those values and I could plug them in and check it out to see if they actually work. Should have worked though, as long as I plug it all in right. But anyway, that's how you use matrices to solve a system of equations. Alright, that's pretty much it. That's all I have about that. That's all I have. Good luck.